Hello everyone, welcome to Almighty Tricks. So in this video we'll be understanding about the linked list data structure. So in this video we'll be covering these topics. One is linked list, why linked list is required, then structure of the linked list and linked list traversal. So these three topics we'll be covering in this video, okay? And these two topics we'll be covering next two videos, okay? So let's get started with why linked list is required. So why linked list is required? So to understand this topic, first of all, we need to understand the cons of array. Okay, what are the problems present in the array? Okay, so let me write the all the cons first, then we'll discuss one by one. So array is fixed in size. Then array stores memory in contiguous manner, contiguous memory allocation. And it stores elements of same data type, right? Elements of same data type. So why I'm giving this array example? Because see, in the array we can store the data. Then why we need linked list? Okay, so to understand why we need linked list, we need to understand the cons of array. Okay, so as we know, array is fixed in size. It stores in contiguous memory allocation elements of it stores elements in same data type. Okay, so let's understand one by one. So suppose I have declared one integer array int a new int of size 4. Okay, so I have mentioned this size as 4. Okay, so let's say this is the memory allocation. So this is the memory array. Okay, and I as I mentioned 4 size, so it will, what it will do, it will create some 4 space here for this a array. Okay, it will create this 4 space. It will not create like this. It will not create like this. So some memory allocation here or some memory allocation here. No, it will not create like this. It will create contiguous memory allocation. So which comes into this point. Okay, this point is fixed in size. Okay, now let's say I am adding one element here, integer type. So 1, 2, 3, 4 I can add. So I cannot add like a character a or a float number. Okay, so this cannot be allowed because it stores elements of same data type. Okay, so this point is also understood, right? Now as as it is fixed in size, we have some data structure called dynamic array. Okay, so what dynamic array is? So dynamic array basically, when we need some memory, more memory, that time it will double this memory. So let's say I have added this 1, 2, 3, 4, right? And let's say I want to add 5 as well. So but 5 is not allowed, right? 4 size is there. So dynamic array, what it will do, it will do 2 into 4 like 8. It will create 8 size. Okay, so let's understand this one. So let's say so basically this is the 4 and I want to add another element 5, let's say. So what it will do, it will create size of 8. This, it will allocate the space of 8 size. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this size it will allocate. Okay, and this will be what? So this will copy here 1, 2, 3, 4. Okay, I mean these elements will copy here. Okay, and it will add 5 here. Okay, but observe one thing, all this space are wastage now. Okay, so memory wastage are happening for the dynamic error as well. Okay, so the issue is here, wastage of memory, wastage of memory. Okay, understood. So So basically linked list, what linked list is doing? So linked list is resolving all these issues. Okay, so linked list is not fixed in size. It is, the size is dynamic for linked list. Okay, and it will store data in random memory allocation. It will not store in contiguous memory allocation. It will store in randomly memory allocation. Okay, and it will store any kind of data, not only specific data. It will store any kind of data. Okay, as we are not storing contiguous memory allocation, so wastage of memory is less in the linked list. Okay, so let's understand this one. Let's understand why linked list is better than array. Okay, so let's say this is my heap memory. Okay, so basically linked list stores memory in the heap. Okay, so this is the linked list. Okay, so I have added one element here, let's say 3. Okay, and somewhere, and also I have added, let's say 4 in the some memory allocation. It is not storing the contiguous memory allocation. It is storing in randomly allocated memory, and I can store some different element like b character. Okay, so it should be object type. Okay, should be object type, so we can store any data. Okay, so this is the heap memory. Okay. So basically so we are not defining any constant space or constant size of the list, and we can store any kind of data. Let's say we are storing 3 4 here, we can store the character or string here. Okay, and we are storing randomly allocated memory, so we are not storing in the contiguous memory allocation, we are storing in the randomly allocated memory. Let's say I am adding another one, let's say 5. Okay, so it means what? It is not increasing the size, it is not doubling the size, just it is creating another space here, and it is allocating the 5 here. So wastage of memory is resolved in linked list. Okay, hope you understood why this linked list is required. Okay, so I'll give one example to understand the structure of the linked list. Okay, so these are the one block, let's say for now. Okay, so linked list will store two things. Okay, linked list will store two things, and these are called and these box are called node. Each box is called node. Okay, and node will have two things. This node will have two things. One is the data, and another is the address of the next node. Address of next node. Why it is required, I'll tell you. So let's say this is data 1. Let's say this is address 1, data 2, address 2, data 3, address 3. Okay, so it is saying address of next node. So if you see this heap example, so we have allocated 3 here, 4 here, b here, and 5 here. But let's say we want to extract this data 3 4 b and 5. We want to know what are the data present in this linked list. So for that, let's say I am coming here, but I don't know where to go, whether I should go to 4 or b or 5. I don't know, right? So linked list internally, what it will do, it will link all these nodes. Okay, this will link to 4, this will link to b, this will link to 5. Okay, so this linking basically is the address. So it's to, let's say this has address 1, it has let's say this, it has address 2, it has address 3, it has address 4. Okay, and it has address 1. So address of node 4 is known by 3. So I'll give one example. Let's say one person named uh, David. Okay, there are 4 person: David, Smith, Abdul, and Imran. Okay, okay. So basically, Abdul know. Let's say Abdul know how the address of the Imran. Okay, Okay, Smith knows address of Abdul. David knows address of Smith. Okay, now Smith want to go to Imran's home. Okay, so how he can go? He will contact with Abdul. Then Abdul will tell that I know Imran's home, so I'll give you the address. So Abdul will give the address to Smith, and Smith will go to Imran's home. Similarly, let's say David wants to go to Abdul's home. So David doesn't know Abdul's address, right? So he will contact with Smith, and Smith will give the address, and David can go to Abdul's home, right? Similarly here also. So node 4 address can be stored by node 3. Node B's address can be stored by node 4. Node 5 address can be stored by node B. Similarly here, so this address 1 is nothing but address of this node. This address A2 is nothing but address of A2. Okay. So finally it will connect like this. Okay. And finally if it is not there, it will be null. Okay. So this this part is called head, and this part is called tail, or it is called front, or it is called rear. Okay, so how we can represent this node, in programmatically? So we can represent, like, we can have one class node. Okay, so here we can have, let's say we are storing integer type data. If we want to store any kind of data, then we can put the object. So I am talking about the Java. Okay, so currently it is int data. Then we can have node of next element address, next node address. Okay, then we have one constructor. Here we can pass the value. Okay, this data will have value. Okay, and this node next, initially it will be null. We can have multiple constructor, but for understanding purpose I am showing only one constructor here, basic constructor. Okay, so this is the structure of the node. So let's understand how we can traverse the linked list. Okay, so let's say this linked list is given. So this is the head, right? So always in the question, this head will be given in the question, and we need to traverse till we get the null. Okay, so we need to print 2, 4, 3, and 1. Okay, let's understand this. So let me write the code first. Let me have one function here. Let's say this is my function x. Okay, so it will give a node head. So as I told, so in the question always it will given as head. Okay, so here let me write first, then I'll explain while. So I'll come to this while part later. Then head equals to head dot next. Okay, let's understand this. So here if you see, I have used head dot next. Head dot next. Why? So as we know, let's say this node address is 204, 205, 206. Okay, so this address can be known by this node, right? 204. This address known by 204. This address is known by this node 206, and this address like 207. Okay, now now the structure we know, right? The structure is like we have the data, then we have the next node. So next node will have the address. Okay, so head dot next. Head dot next means what? This is the head dot next. Head dot next means what? This is the head dot next, right? So if I do head dot next means what? This node. Okay, head dot next is what? 204. So 204 address is this one. So if I do head equals to head dot next, then it will point to this node. Now head will come here. Okay, right? Similarly 20 this 205 address is address of this node. Okay, again it will come. So now this head will point to here. Similarly, 206 is address of this node. So this head will come here. Okay. Now you observe here. Now we don't have this any node here. We don't have any node here, and here address will not be there. Okay. Address is null here, right? Let me fix this one. Address is null here. Okay. So as when we'll check if head dot next equals to null, not equals to null, till that time we'll go through this loop, right? Otherwise we no need to go. If I go till head dot next equals to null, then it will give the exception, right? So here I need to put head dot next is not equals to null. Got it? Got it? So till that time it will loop. So finally it will print 2, 4, 3 and 1. So what is the time complexity of this code? The time complexity of this code is order of n, number of line. Okay, and so basically this is not a correct code. Okay, so if you observe one thing, so the point is here, the note takeaway is never ever move your head. Okay, what I mean I'll tell you. And the second point, create a variable and store head. Okay, now understand this note. This is the important one. Okay, this is the important one. Let's say currently this is the head. Okay, this is my head and some node is present here. Okay, now let's say head is pointing to here currently. Now head is pointing to here. Okay, now let's observe one thing. If I'm coming to here, if I'm coming to this node, then I'll lose this node, right? I'll lose this node because head is currently pointing to here. There is no way to come to this point. Okay, so I'll lose this node. So better every time what you need to do, you need to create one backup variable. Let's say node is equal to temp is equal to head. So by doing this, so head will be stored as it is, and using this temp we can write the code. Let me write the code. So I'll write the while loop. Temp is not equals to null. Till that time I'll go one by one. Temp is equal to temp dot next, and I'll print temp dot, what is that, temp dot val or value. This is data, right? Temp dot data. Okay, so this is my closing bracket. Okay, so this is the code. The time complexity is still order of n. Okay, so hope you understood this details of the linked list. So we'll see you in next video.